Testing, testing, testing. Okay, 1, 2, 3. I'm shifting gears into actually tutorials. So if you're interested in making something like this, it's pretty slick, even though you may wonder why it looks like the way it does. Well, it's totally openable, interchangeable, pretty wonderful to play with. It is, well, bottom and then 1, 2, 3, 4, 5, 6 slabs that can be brought together, and it's completely parametric to change its model and change its form. If I was to put that into shaded and show you what we have here, we have a completely incredible parametric script that can be altered and changed by the sleight of hand. So let's jump over to D and build this thing from scratch. What I'm going to do is try to talk a little less and show what I'm doing. I'm going to grab a square tool, and I will bring in the one plugin I like, which is bifocals. Bring in a square tool, and I'm going to show you what I do and walk you through it. I'm going to set my size to slide my size up to 10, simple integer value, and I'm going to take my extends and set those both in the X and Y direction as 2. With that data, I am going to simplify that data. Then I am going to do a region union and bring my cells in so I can have a section. And in flattening that, you can watch what happens. It just goes to the edges. And I can grab myself a surface. And I think I'm going to try a different format of showing you what I'm working on. This is going to be my base, and I'm only going to extrude my base down. But I'm going to leave it because right now we're just producing surfaces. That's the first surface I want to produce. The other surfaces I want to have control over. I'm going to go in, I'm going to flip this matrix. And I could show you the data and why I'm doing that, but I don't have a lot of time to do that. I'm going to show you the points that come out of there. And I'm going to take those points as I bring them out, and I'm going to graph those. You'll see why in a minute. And I am going to take that geometry and I am going to orient those points to something. So let's go into Euclidean, orient. Those points are going to be oriented from point 0, 0, 0 to some target points. And those target points I'm going to create right now. Create some points, and I'm going to use multiplication factor because I'm going to play with trigonometry. I'm going to play with that trigonometry 3 times. And I'll just show you what we're building. It won't function until I'm done. Sometimes I write my script backwards. I am going to go into my maths and use my cosine. And I'm going to use my sine because I want a helix. And I'm going to plug those into B and B. And I'm going to use a series, which will default to pretty much where I want things to be. I will set this one in case I want to play with it 1.00 to change the step lower. And I will set a 2 integer slider up to 10 for my count, and I will feed that into my height of my z, and you'll see what happens here. It's very, very tiny, right? Hard to see right now, but what I'm going to do is amplify all this by, let's just say 4.5 slider. Amplify that, amplify that, amplify that. And what I've ended up building by doing this is a helix. Now that helix is where I want to orient all those other points. And there they are. They've all been set up. So if I was to change my count and you can see how those play off of what's there. And I'm orienting those to those points. And that should make a little sense. And that's where I'm going to begin. I do not need to simplify this data, but there's 2 ways of simplifying it if I did. Say I was looking at my param viewer quite often. I see what I have here, but since I need all the data, simplifying it is kind of useless. When I change out simplifying, it doesn't change anything. And another way I'm just going to show you is I do simplify data quite a bit just to keep things manageable. You can always bring it in this way and take it out and see the same data. I'll leave it in there even though it's unnecessary. I also like to use my path mappers to see data, and I'll plug that in, right click, and do null data. But whenever I don't see an indices in here, I'll left click twice, and I'll add my indices in parentheses, and I'll add my indices in parentheses. and I'm going to use that twice, and I'll show you exactly what I'm doing with it. Well, I'm not going to use it twice, but I'll show you what the first interpolated curve looks like if I was to just interpolate what was set there. And there it is. Some very nice curves that have all been oriented, and they're all ready to go. I'm not actually going to use that. What I'm going to do is use my path mapper to feed in things like the relative items. And relative items is a way for me to control where I want things to go. I'm going to show you a couple examples of relative items. Let's bring that tree in here. Let's bring that tree in here. We've got items selected and items not selected. And here, you've got to set up a system that looks like this data. You've got to read with the squiggly lines and with the parentheses and kind of what I've written in here, how I would control those offsets. So I'm just going to do a quick quote 1, so I have a number here. I'm going to turn that into multi-line data. I'm going to go into here, and I'm actually going to write squiggly brackets 2:0, because I'm walking through my data, and I'm going to do my parentheses 3. I'm going to show you what this little script kind of does as an offset. It allows me to choose certain amounts of data throughout that structure. Now think about making surface from points when you get into this. I'll make one there, I'll make another one here, and I have many examples in the file that I'm putting up on GitHub. Let's put this one in the offsets, and let's play with this a little bit. Let's swap out the 2 and the 0, and see if we play off of some interesting data here. So I've got this set running this way, and this set running this way. That starts to make sense to me. And of course, to visualize it, I will go in and I will interpolate. Interpolate that one, and interpolate this one. And those are the chosen ones that I've chosen to do. Now, if I start thinking of those as what I could do with those as curves, and if you want to see the curves always, without having to get lost in this node of what interpolate is, even though it's basically making curves, I'm just going to take a look at it. I'm going to take those curves and I'm going to run them along a rail sweep. Now, I have to be very careful with this, sweep one rail and sweep one rail, and I'll show you why. And this gets pretty interesting because I'm dealing in sine and cosine. My curves have been shifted. So even though they start here on the 0 in the x at 0, y starts at 1. So you're going to have to do a little bit of fudging on this data. I'm going to show you how to do this. So as I start thinking of sections to rail, I am going to take my flip data interpolated curve right here, and I'm going to take my I'm locked up in Rhino window. I'm going to take my flip data here from my original. Now take a look at those curves. One goes this way, one goes this way. Well, those are nice systems to drag along rails, and I want to make sure that I choose the right ones. This one I'm going to push up because I'm going to use that later. These are my curves that I'm going to try and run along as the sections to here, but they are a little, one of them has to be stepped in another direction. And let me just double check. I believe my one coming from my actual, this one coming from actually here needs to be staggered because of the sine and cosine situation. So what I'm going to do is just quickly move this data in the y direction to compensate for that shift in my geometries. This isn't making sense. You might have to look at it a couple times. I'm going to take a math tool and divide, and I'm just going to use a quick double click quotes 2 because I want to divide by 2, and I want that to be my motion in the y, but of course I need to feed it the information how far I want it to go in the y, and I'll take my 9, actually I'll take my 10, and I'll slide that over into my y. You'll see what I have now is those lines have moved. They moved from here to here, and that's to compensate for the fact that this curve is not starting on the 0 in the y, so I had to move it by half. And now I've got a rail system that I can actually plug into these sections. And you can see what funkiness happens there. Let me take my rail system and put it into this section. And have a look for a second, because I have changed my numbers just slightly. Rail system down here is going to be my, actually, I've got to put these into my sections, and this into my rail. I've got to put these into my sections, and this into my rail. And look what we have. A very nice, this side and this side. Really nice data. And in doing so, where have I grabbed my data? I'm down to 1 on each in these sections, which is very nice. But I'm taking a look and I'm saying that data sweeping across these rails is not adhering to all three of these. In fact, they've gone in the right direction, but I actually have to have this as my rail system here, and this is my rail system here. Otherwise, I don't get 3 and 3. I get 1 and 1. So that's a little bit of jumping and jostling at the 10-minute mark to figure that out. But it's an interesting system. It gains a lot of control. I'm going to merge this data in here. And I've got those systems, and I want my base. And that's basically it. And I haven't extruded my base yet, but I'll do that later. At this point, I'm ready to grab a surface node, pack everything in, and start to do some very interesting things with this. And what I'm going to do to that surface, just so everything makes sense, is I'm just going to reparameterize it. That's as far as I wanted to get in 10 minutes, which was building a very interesting system of the base. And I could bring it in here, but I'm not going to. I have this system, this system. I'm going to loft these all separately and differently, and you'll see exactly why. Otherwise, it gets messy. So these two systems are ready to go, and that step there still needs to be that base. Has to go through the same manipulation as to what I did here. So I have to grab that move and that vector, and I have to copy this, and I'll be doing this later, but I have to move that data also up. So there we go. Now I have the geometry I want, which is these two that line up. I've got a very cool tool. Now it's only surface, it's not solid, and making this solid is going to be the real trick as we step into the second half of this script. So let's start with that one. Have fun with it. I'm going to grab them and group them. I'm going to grab everything else and make it invisible. And there you go. You've got a nice system to start. You could take a bake of that just to check for, you could take a bake of these and just check for everything being beautiful. Jump into here. Oh, what's nice is you've got all your sections separate. You could make this out of sheet metal. This is far enough, but I'm going to take this into solid, and that's going to be the real trick to the second half of this. Let's pull it into render. We've got a bake on here. Let's just throw it in zebra, which is always ugly, but why not? There we go. And we can take that and rotate it. And you can see that you've got a very nice form that's capped at the bottom, and there's a little bit of trouble here. I've got a little bit of a stagger here on a step, and I have to wonder why that's overlapped just one count there, which makes me think I pushed it just a little too far. And that could be a little bit of data here that I have to look at, and it could be just a count for a move in the Y vector. And that's something I just have to subtly do. 10, probably having to just do a little bit of math here that I didn't catch on my last one, which is always good to see. Let's grab a minus, quote 1, because we're dealing in units. Let's put that 1 into the minus. Let's put the 10. This is going to be a little ugly here for a second. As I bring this up here, it'll fault out. Put this one here, and take that 10 into here. And hopefully that will step it back a little bit. And I think it did, but it's hard to say. Let's go back into our data and see if that one's right on the money. And it is. I just had to do a little bit of math to fix that up. Let's throw that into a bake and just clear that up. And there we go. And we can take that into an EMAP. And we've got the base as silver in the other ones. So I just had to do a little correction. Sometimes you have to do that. You have to play with your scripts so they end up being perfect. Thanks very much for watching. We're now going to take this into, if I jump back into this one, let me just save this for a second. Let's go back into C, which I have done. You're going to see that I'm going to take this geometry and make that one solid and have some real fun with the thickness of these sides. And it's going to be this script here, which is fairly repetitive, but you'll see why I have to make it repetitive. We'll start by thickening the sides, and then we'll jump in here. And what's nice is a very fast-moving script. Still, in the end, it's a very fast-moving script at 15 milliseconds to extrude and change all of these things. So stick around for this, and I'll show you what we're going to do. And I can take my extrusions differently, and I can simplify this side of the script. But right now, I just wanted to show you a little bit of value of how you can really have fun with that, and not just there, but in your offsets, you can really start to play with some cool forms here. So you start making some very cool geometries from this, and that's the power of this script. So I'll just do 30 seconds of just swapping these out to entice you to keep watching what I'm doing. And yeah, it's understanding your offsets and understanding your data and understanding the geometries and shelf units and what you want to make by data alone. Very cool system. And there's another one. All right, thanks for watching.